going to be looking at the Edexcel FP2 question on complex numbers from June 2011, question 5. In this question, P represents a complex number Z, and we're told that the modulus of Z minus I equals 2. The locus of P produces a curve C, so we need to find the Cartesian equation of that curve C. We need to sketch the curve C. Then after, we have a transformation T which is applied to the Z-plane to produce the W-plane, and that transformation is given by W equals Z plus I over 3 plus IZ, where Z mustn't be 3I. Okay, the point Q is mapped from T onto the point R, and given that R lies on the real axis only, we've got to show that Q lies on the curve C. So in part A, we're given that the modulus of Z minus I equals 2, and we have to find the Cartesian equation. So we're given the modulus of Z minus I equals 2, and we're going to let Z equal a general point on its own plane called x plus iy. So this means the modulus of x plus iy minus I has to be 2. Quite a neat thing to do now is to collect the real and imaginary parts together. So the real part is x, and the imaginary part is y minus 1i. So now when we take the modulus of this complex number using our traditional method, we're going to get the square root of x squared plus y minus 1 squared is 2. Squaring both sides, we get x squared plus y minus 1 squared is 4. And that is the Cartesian equation of C. The mark scheme for this part of the question allocates a method mark for attempting to find the modulus of Z and an accuracy mark for the answer. In part B, we simply have to sketch the curve that we've just found. Clearly this is the equation of a circle, so it's worth writing down the centre of the circle, which is at 0 plus 1, not minus 1, it's at 0 plus 1, and the radius is the square root of 4, which is 2. So your sketch needs to show those two bits of information as clearly as possible. So we've got x, y, then we have a circle, centered at the point 0, 1. The radius is 2, so the y-intercept needs to be 1 plus 2, which gets me to 3, and 1 take away 2, which gets me to minus 1. That is sufficient for the marks, but also if you look for the x-intercepts, you can also show, if you wanted to, the root 3 and the minus root 3 when y is 0. The mark allocation for part B is a method mark for drawing the correct circle and an accuracy mark for showing the centre at 0, 1 and the radius is 2. In this part of the question, it's worth just taking a second or two just to check that we can see what's going on here. So we have a point on the Z-plane, which is called Q, and that's going to be mapped to a point on the W-plane, and that is going to map Q onto R. And the thing that's mapping Q onto R is the given transformation T. Okay, so that given transformation is defined by W is z plus I over 3 plus iz. And you can see that we mustn't let z equal 3i, otherwise the denominator would be 0. So what we need to know now is what t is going to do to a general point on the z-plane. And that general point, Q, I'm going to call xy. So W is going to be x plus iy plus I over 3 plus I times x plus iy. And it's worth simplifying this before we go any further. So in the numerator we can write as x plus y plus 1 I, and in the denominator we have 3 plus ix plus I squared y. So again, tidying up a little bit more before we go any further. So there's 3. I squared y is going to be minus y, so this is going to be 3 minus y plus ix. So what we need to do now is to rewrite this expression for w, and in order to do that we need to multiply top and bottom by the complex conjugate of the denominator. So we're going to multiply the top by 3 minus y minus xi, and we're going to multiply the denominator by 3 minus y minus xy. So the top, when you multiply it, expand the top, becomes x 3 minus y plus x y plus y 1. So I'm putting the real parts together. Then we have y plus 1 times 3 minus y I, and a minus x squared I, and all that is divided by, and the denominator is going to be 3 minus y squared, and then minus x squared I squared. So that's minus x squared, and I squared is of course minus 1, so this negative becomes a plus. Then we're told something really important. We're told that r is on the real axis. So if the image r is on the real axis, that implies the imaginary part must be 0. So we need the imaginary part to be equal 0. So if we pick out the imaginary part now from this, so I'm picking out the imaginary part. So the imaginary part must be 0. And in order for that to happen, we need the numerator to equal 0. And the numerator is going to be x squared plus y squared minus 2y minus 3 equals 0. And if we complete the square on the y terms, I get y minus 1 squared. But I need to take off a 4 there in order to complete the square. In other words, x squared plus y minus 1 squared equals 4. And that is the circle that we had earlier on. So that shows that Q lies on the original circle C. Okay, so the condition for x and y was the original circle C, so that's where Q must lie. The mark scheme for this part of the question gives a method mark for rewriting W in terms of X and Y. It gives a method mark for multiplying by the top and bottom by the complex conjugate. It also gives a method mark for realising the imaginary part must be 0. An accuracy mark for letting the imaginary part be 0. And an accuracy mark for finding the correct circle. Notice we were told that Q lies on C, so that last accuracy mark requires a complete solution only. It has to follow a correct, precise method. There is further information available on the Further Mathematics Support Programme at the website www.furthermathematics.org.uk.